Welcome once again to biology lesson where we discuss biology from 1 and we are on topic 3 where we are going to discuss recording measurements. In biology, there are so many kind of measurements that we are supposed to know how to record them. There are so many kind of measurements that we are supposed to know how to record them. So that is what we are going to dwell on as we discuss in this lesson. However, I want you by the end of this lesson, you should be in a position to record measurements accurately. Record all the kind of measurements we are going to share accurately. Be there as we explain more. Now, recording measurements. So measurement is the act of determining the quality of something accurately. Measurement is the act of determining the quality of something accurately. Bullet 2, variables such as temperature, height, volume, time, length, and area can be determined through measurements. I'll come again. Variables such as temperature, height, volume, time, length, and area can be determined through measurements. Despite there are so many measurements or variables that can be determined through measurements, but that was to mention a few. So during measurement, it is important to make sure that the value of the measurement is accurate and that it is as close as possible to the true or the acceptable value, which means when you happen to measure, make sure that you make it as accurate as possible. If there are already acceptable values, make sure that your measurements are as close as those which are acceptable or the possible true values. Yeah, so for example, let us look at an example. The temperature of a normal adult was usually 37 degrees Celsius, which means the temperature of a normal adult should be as close as possible to 37 degrees Celsius so that it is considered accurate. So, repeating measurements several times during experiment ensures precision and encourages accuracy. It encourages accuracy. Yeah. So this is very important and you also need to know it. But before 1960, there were several systems of measurements in use around the world. And in the same 1960, an international system of unit was established. The reason for it to establish so that all scientists must have a specific type of units to use. So this system is called the International System of Units, the CI. So the table below shows some measurements and their symbols and their system unit. So some measurements and their symbols and their SI unit. These are not all the measurements which the international system organized, but just to mention very few and to see what they did or what they agreed on. So length, they said at least measuring length using meters and the symbol of M to represent the first letter of the word meter. Then mass, the symbol of K and G, which is kg. Then the CI unit is kilogram. Then time was supposed to be, they agreed to measure time in seconds and with the symbol of S. Then temperature, they agreed on to measure this temperature on degrees Celsius. This is the symbol for the degrees Celsius. So these agreements were made so that all measurements and learnings should be the same. So that again, everyone should understand these kind of measurements worldwide. So we'll use some of these measurements as we are going to record measurements in this lesson. Now, let us start with the measurement of length. Measurement of length, as we want to discuss how to record measurements. Now, length is measured in meters. Length is measured in meters. Although 1 meter is the standard unit of length. 1 meter is the standard unit of length, but it is sometimes too big for you to measure using meters, or too small for you to measure using the same meters. So, in other ways, you may also use other units to measure this length. Meters are just placed there as standard units, but if you find that the length you want to measure is as long as meters cannot be used properly to measure it, you are supposed to use different type of units. So, the other larger or smaller units related to meters are used to carry out some measurements are in this table below. So this table is helping us to see other standard length and its relationship with the smaller units of length and the larger units of length. So this table is helping us to have other bigger units if we are to measure length, and the other smaller units if we are also to measure length where meters cannot properly fit in. Now, we may have 1 kilometer. 1 kilometer. 1 kilometer, in symbol it is km. In symbol it is km. When we want to compare these kilometers with the meters, 1 kilometer is giving us 1,000 meters. Is giving us 1,000 meters. So, which means if you happen to have bigger length to measure, you might also use kilometers as the unit for measuring this length. Because if that length is too big, then meters might require a lot of time for you to finish. So others might use kilometers. Then meters themselves, with the symbol m, and meter in comparison with other meters is just the same as 1 meter. Then 1 centimeter, with a symbol of cm, as comparing it to meters, you have 0.01 meters, 0.01 meters. And 1 millimeters, with the symbol of double M, that is compared to meters as 0.001 meter, 0.001 meter. So, centimeters and millimeters are smaller symbols which you might use when you have a smaller type of length. But if you have bigger, you might use kilometers. But in general, we have discussed that meters are the you may measure length normally in meters so that we attain that international system. So other instruments that can be used to measure length might include rulers, tape measures, and meter rulers. Remember, we have just said length is measured in meters, but the materials we might use for us to measure that length could be rulers, tape measures, and meter rulers. And these are some of the materials, and this is a ruler. This is a ruler. This ruler, you might use this ruler to measure length, and there are so many rulers with different type of units. Some are meter rulers, some are centimeter rulers, and some are millimeter rulers. Then we have the tape measure. The tape measure, this also is an instrument you might use to measure length, and it is also having units in meters. Now, assuming you have learned how to measure length, now you want to apply it on a certain thing. Now I have brought to you how you might measure a wooden block. How you may measure a wooden block. So this is an activity coming to you so that you understand more about how you might measure different kind of objects. So to measure length of a wooden block, what you need to do, place the meter ruler in contact with the block. I'll show you in the diagram. Then the zero mark on the scale is placed at the edge of the object. If you happen to use a ruler, that ruler begins with a zero mark. If you are to use a tape measure, also begins with a zero mark. So where you have the zero mark is where you are supposed to place at the edge of the object. Then position your eyes light vertically above the other end of the block. As also shown in the diagram, I'll focus much when I bring you the diagram. And again, read off the measurements. Then from there, repeat the procedure. This time, measuring the width and the height of the block. So you may measure if this block has got the length, you measure the length, and then you measure the width and then the height of this block. So this could be the example of the block that I wanted you to see, and look it carefully and see there are some position I have put the eyes there, and those are the position I want us to compare. Now this is our measuring ruler. This is our measuring ruler, and here down here we have the block, and this is the block down here. If you are carefully looking at it, you might observe that there is a block and a ruler placed on top of this block. And then this ruler, I have placed it at the edge of the object. This being the object, the ruler begins right at this edge, and then it continues up to here. But the block ends here. Now, I want you to correctly see the position of the eyes, position of eyes. Look, if this was you to observe the correct measurement from this block, you were not supposed to see from this angle. You see where I am pointing? You are not supposed to see the measurement of this block, this ruler from this angle. So this is in a correct position. I have written C. That shows in correct position. And again, there is another type of an eye which is here at B. Also, this is an incorrect position. This is an incorrect position. But if you are to observe the measurements from this block, you could have looked at the vertical line, the vertical side of this measurement block. So this is the correct eye position. This is the correct eye position, which means your eyes are supposed to be positioned vertically above the other end of the block. So which is here, above the other end of this block. So that has been a very good observation. But as you continue to do that kind of thing, when making readings of the measurement using a ruler, it is important to position your eyes vertically above the reading to make correct readings. So that has been the measurement of the length. Now let us switch ourselves to measurements of temperature. Measurement of temperature. Like what I have already said, we will discuss different kind of measurements here in this lesson. Now we have to share on how we might measure temperature. Have you ever heard about the word temperature in your primary section? Yes, I believe so, because temperature is one of the common words used in mathematics and science, primary science. I should say that. Now, thermometers are used to measure temperature of different objects. Thermometers are used to measure temperature of different objects. For instance, I want us to have an activity where we have to demonstrate on how we might measure this temperature. Now, we are going to demonstrate on how to measure room temperature and boiling temperature of water. So we will need to show room temperature and boiling temperature of water. If you are to measure water, there will be some materials that you need for you to measure this temperature of water. But remember, the other type of water will be boiled. The other type of water will be room temperature. Now, materials you may need: 1, the same thermometer, and 2, beakers for you to use to hold the water, and then the tripod stand to hold those beakers, and a means of heating if you are to boil the water so that you raise the temperatures. So those materials, if they are available, then you will have room temperature and boiling temperature of this water. Then this could be the procedure for you to use. 1, half fill the beaker with water, which means you have 2 beakers, one with hot water and the other one with room temperature water. Then 2, place a thermometer in the water and leave it there for 2 to 3 minutes. So this could be the way how you can place the thermometer inside the beaker. Thank you. Now, on the temperature, make a reading and record the temperature of this water in degrees Celsius. Then 4, you might do it to the same, but to the other type of water. Or if you didn't boil, then place the same setup on the tripod stand and heat to boil that water. Then take the measurements of the temperature of the boiling water. Remember, take care that the thermometers should not touch the beaker. Is it important? You are boiling the water and then you want to measure the temperature of the boiling water. And then the thermometers are touching the beaker at the bottom of the beaker. Do you think this will affect the results? Yes. That is definitely going to affect the results because the heating of the beaker and the water might be different. So this might affect the results as you prepare them for the measurements. 6, record and compare the temperature of the water, which means room temperature water and the boiling temperature water. That could be the way how you might measure the temperature of 2 different water. So now we might also measure the volume of all substances which can be measured. But now, in this case, we're supposed to focus on water as a very simple example. So volume is the amount of space occupied by a substance. The standard unit of volume is the cubic meter. Remember, in the laboratory, volume is measured using apparatus such as measuring cylinders, burettes, and the pipettes. So this could be the cylinder, and it is measuring the volume of a liquid substance like water, like what I've already said, water. So, being the diagram that you have there, we have water inside it, and there is the eyesight position. Eyesight position. Where are you supposed to view as you are measuring the volume of any type of a liquid? But in this case, we're using an example of water. Any kind of liquid that you want to measure. So, there are 3 different eye positions here, and there is an eye position which is on top here. This is an incorrect position of the eye. Remember that is an incorrect position of the eye. The correct position of the eye, it is the eye which is at the direct position or the level position of water. The water in this cylinder is at this position, and the eyesight also is supposed to be at that position. But again, note this. Looking down as you look up to see the level of water. This is also incorrect position of the eye. So this is how you might read a measuring cylinder where they have filled some water. But there's something that you could have noted as you also measure volume of substances. In the cylinder, most liquids, they make a meniscus. They make a meniscus, which is, they make more like a curve. More like a curve. So when you are reading, you should remember to also take note of such kind of curves. Now this table might also add on what we might have on volume. Remember, we have just said volume is measured in cubic meters. But these are some of the standard volume and its relationship with other smaller units of volume. What does it mean? Meters could be there, but some other type of liquid could be in a little amount, or in a more or plenty amount, which might also need other type of units. So here is where we compare other type of units. Now we might have other units like liters. So 1 liter is compared with a cubic centimeters, but 1 liter has a symbol of L, which is compared to 1,000 centimeter cubic or cubic centimeters. 1 milliliter is just the equivalent to 1 milliliter, which is supposed to be also 10 centimeter cube. Then 1 centimeter cube is just equivalent to 1 centimeter cube, and is just the same as 1 centimeter cube. So that is a comparison of other units which you might use when you are measuring this volume. So you may measure volume in liters, you may measure volume in centimeter cubes, and again, you might measure this volume in milliliters. Yeah, let us continue. That has been a volume, and now we can see another type of measurement. Now let us measure area. So let us look at measurements of area. Have you ever heard about the word area? Yes. Very common in your primary section, where you were calculating the area of figures, shapes, so many things. Now, an area refers to the amount of space that a surface or a region covers, meaning anything that covers a space, it is taking a certain area. That means that space can be calculated. And the standard unit for area is square meters with this symbol, meaning this 2 is representing square and the M is representing meters. So there are other smaller and bigger units of area, including millimeters square, centimeters square, and kilometers square. To add on meter square, you can also have millimeter squares, centimeter squares, and kilometer square. Or you might say it in this way: square millimeters, square centimeters, and square kilometers. Of course, I feel like it sounds the same way. Then the area of an object is obtained by measuring the dimension and then applying the appropriate formula. That is L, this is times W. L times W. Of course, that L is representing the length of that object, and W is representing the width of that object. So this could be the very good example where we have a shape, and this shape looks to be a square. Why a square? Here we have the same measurement with here. So the other side could be used as the length, the other side could be used as the width. So the area of the figure above is L times W, where L, I have already said, is representing length and W is representing width. If you are to calculate the area of this shape, you may just substitute where there is L, you put the value of L, which is 1, and the W being the same, you also put 1. And then if you multiply 1 times 1 in mathematics, I think the answer will be just the same with mine here, 1 square meters. I think you find it the same way. Now, I have taken you to a situation where I feel like that is not enough for you to understand how to measure area. Assuming you are in a real-life situation where you wish to find this area without calculations. So, you may also measure and determine the area of the classroom. You may also measure and determine the area of a classroom. Now, what could you do? Remember, first of all, you may need some materials. What materials can you have? The tape measure. We have already said we may measure using that tape measure. And then notebooks for putting the recordings. and then the pencil for writing those recordings. Then this could be the simple procedure you might follow. But before you continue with this type of measurement or this type of an experiment in your life, you may not do this alone. Assuming to say, under this procedure, I have said you should work at least in pairs. If you are many, you can work as a group. So one, work in pairs. Hold the tape measure at one corner at the front of the class. One of the things that you need to do is to hold the tape measure at one corner at the front of the class. This will be the starting point of your measurements. And then let the second person stretch the tape to the other corner of the classroom at the board to measure the length of the classroom. Which means if you have that classroom, you take corner to corner of that classroom, which means you may start with one side at a time. Then from there, repeat the procedure to measure the width, which means if you started with the length of that block, then you may measure now the length of the width now of the same block. So record your measurements on the notebook using the pencil, and then you may finally calculate the area of this classroom. And for now, you might be able to understand the formula. If you started by recording the length, you record those measurements, and then you record the width, you also record those width, and then you use that type of the formula we have just shared, that you multiply the length of that block and multiply the width of that block. If you do so, then you happen to get the correct result. Then finally, you may compare your results with that of other students if you happen to you were so many as you were doing the same experiment. So please, that could be the thing you might do as you wish to get the correct results. So comparing is also necessary. Comparing is also necessary. So that has been the way how you might calculate area of different type of shapes. Despite we have just shared one type or one shape of area, there are so many type of shapes that you might also calculate their length, which means, their area, which means in such a case, you'll also be provided with a different type of approaches so that you also happen to have a very good way of calculating the areas of such kind of shapes. So for today, I have just used one example of a shape that you could use as I gave you the formula. But there are so many kinds of shapes. Now, let us jump to another type of measurement where we may talk about measurement of mass. Measurement of mass. Mass is also measured. Mass is also measured, but this mass is the quantity of matter in a substance. Yeah, mass is the quantity of matter in a substance. And the standard unit of measuring mass is kilogram, with the symbol of kg. Yeah. So this could be the relationship between mass in kilograms and other larger and smaller unit of mass, like what we have just discussed to other type of discussions. Mass can also have different type of weight. That's what we can say. Yeah. So we might also require different type of units as we measure this mass. There are other mass could be larger, other mass could be smaller. So using one standard unit could affect some of the results, as some could be larger or some could be smaller. So we may have 1 ton, which is represented by the symbol T, and this is just equivalent to 1,000 kilograms. So in comparing with kilograms, the unit which we already have as our standard unit, you may have 1 ton, which is just equivalent to 1,000 kilograms. Now, if you have bigger units, you might use the ton so that you get at least a smaller number and you finish the measurements faster. 1 kilograms is just equivalent to 1 kilogram. That's just it's just okay. And then 1 gram is just, which is represented by the symbol G, is just equivalent to 0.001 kilograms. 0.001 kilograms. So 1 milligrams also is represented by the symbol mg, which is just equivalent to 0.0001 kilograms. So this is just a comparison as you compare other units to the standard unit that we have as we measure this mass. So take note of all those units because you might need them as you look into different type of mass, larger and smaller type of mass. The larger the mass, you use the larger type of unit. The smaller the mass, you might also use the smaller type of unit. Yes, let us continue. Now, the mass is measured using so many type of machine, normally using the balances. So I have brought a table that shows type, not a table as such, but figures that show many types of apparatus for measuring this mass. So the first thing could be the beam balance. I think you are able to see the diagram properly. Yeah, that's a beam balance whereby you place the other side mass, the already calculated mass, and then you put other mass which you want to calculate in the other box. So if they balance, then that means you have the accurate results which you are looking for. And also we have the traditional pan balance. Traditional pan balance. Here are some of the already calculated mass. Could be either 200 grams, 500 grams, 1 kilograms, 2 kilograms. It doesn't matter. Whatever type of mass you use, it will also help you to determine the type of mass of something which you use to the other side. So if they also happen to balance, they level it, if they come to the same level, then that is a sign that you have really measured that according to the mass you have used. So you take the readings of the material you are measuring according to the mass you used to balance them. And on top of that, you might also use this modern top pan balance, which is also used to measure the same mass. So these are some of the things you might use as you measure mass. These are some of the things you might use as you measure mass. Now, also under this mass, you might also be affected with some of different kind of units. But now I have taken you so far where you are also supposed to demonstrate on how you may measure the mass of a fruit. Mass of a fruit. Assuming that was not enough for you to understand and appreciate the explanation I gave you. So let us see how we may measure the mass of a fruit. Materials for you to need could be the weighing scale. That could be those beam balances and a variety or various types of fruits. Then what could be the procedure? 1, place the fruit on a weighing scale, either the traditional pan balance, and then read the weight. Record the weight in grams. Record the weight in grams, and then you'll find that you have the correct results from there. You may repeat that kind of an experiment so that you get more readings or more accurate readings from there. That has been a small or brief type of measurements that I could have brought to you. And now let us see how we might measure time. Time. You have ever heard about time? Yes. In primary sections, you were learning mathematics, talking about time. And also, you have been wearing wristwatches, checking about time. So time is one of thing that you might measure as you study biology. So let us see how we might measure time. Time is the duration a particular event or activity takes place. The standard unit of measuring time is the second, and its symbol is S. So this time is measured using watches and clocks. These are the things that we might use to measure time. So these seconds are the smallest units that we might use, but there are so many types of units that you might also use. But before we come to that, let me show you examples of watches or clocks. This could be a digital watch, a stopwatch, a stop clock. These are some of the materials that are used for measuring of time. Now, the relationship between time in seconds and other larger units of time, like what I have already said, seconds are the smallest unit to use when measuring time. So you might be compared to other type of units which also could be measuring the same time. So these are some of the units which might help you to measure the same time. You might measure a time in a day, which is equivalent to 86,400 seconds. Just a day is just equivalent to 86,400 seconds. 1 hour, which is abbreviated with H and an R, this 3,600 seconds. 1 minute equivalent to 60 seconds, and 1 second is just equivalent to 1 second. More and more units can come to you as you study, because these are just very few examples that we might use. You may compare this time in week, fortnight, monthly. You may go to annually. You may go to Instagram, score, Olympiad, decades. You go to maybe silver jubilees. You go to human generations. You may go to diamond, golden, centuries, up to infinity. So such kind of things, they might be, as those units, all of them can be used to determine the time someone has taken, or someone has done such kind of an experiment. Now, let us have a simple task where we wish to measure time using a stopwatch. What do you think you could do? We have just shared that time is measured in seconds. But now, how would you use those stopwatches? How do you measure this time in those seconds? Now, this is a simple task that we need to share as we wish to learn more on how we may use or measure time using a stopwatch. First of all, you may need some materials. One of the materials should be the same stopwatch, and the other one, school field, whether a ground or any type of a field that you might identify. And again, notebook, where to record the stopwatch, and pens to use on recording those readings or measurements. Then the procedure for you to follow. 1, work in pairs. Why? Someone should be holding the stopwatch and someone should be doing the activity which you are measuring. So, work in pairs, one of you to take the time and the other to do an activity. For instance, this time, to run. So, you want to compare how many seconds he is taking as he is running. So, the activity in this time, it will be running. 2, start the stopwatch and time how long it takes your partner to run 100 meters. Then stop the watch. Yeah, that could be the activity. You want to see how many seconds this person is going to take as he's running a 100-meter ground. And then as you start, then after reaching the final point, you stop the watch. Then note down the time in seconds. So allow your partner to do the same, and so that you get more accurate results. As you do so, you'll have an accurate time when this person takes as he's running a 100-meter ground. Thank you. That has been measuring time. Now let us go to how we might determine surface area. Determination of surface area. We have just covered area, and now we're talking about determination of surface area. Yes, these things might come in 2 different ways. Why? Because the surface area is the total area of faces of a solid figure, while in measuring of area, we just shared the area covered by any object. But this time we are saying a surface area, it is the area or the total area of faces of a solid figure. I hope I have already made a difference there. Now, this is obtained by adding up the area of all surfaces in the figure. Yeah, is obtained by adding up the area of all faces in the figure. So this could look more simpler if we have the figure. Now I've brought a figure below, and that has the length of 2 centimeters with width also 2 centimeters, and also has the height of 2 centimeters. So in general, this could be a cube, and therefore has 6 faces. Therefore, we wish to find the surface area. Something with 6 faces, what do you expect? Which means there are 6 faces which we need to calculate their area and then put them together. That's what we have discussed in the definition. So, this could be the shape of the cube with all faces the same way. Length 2 centimeters, width 2 centimeters, and a height of 2 centimeters. This will allow us to have 6 faces. Yeah, the way how the diagram looks. So for you to calculate the surface area, you'll need to calculate the area of all those 6 faces and add them together. I have calculated the area like this, like the way how I've demonstrated. Face number 1, 2 times 2, then you add, you also multiply the second face, 2 times 2, 2 times 2, 2 times 2, 2 times 2, and if you sum up together, you find the answer as 24. But because it is the area, it is supposed to be found in square centimeters. So that is the way how you might calculate the area of the surface area of any solid shape. I hope I have made it clear. So that is what you might do as you wish to calculate the surface area of a solid shape. Now we may jump to another thing. That could be determination of force. Determination of force. Force can also be measured. Yeah, force can also be measured. So let us see this situation. Suppose you are playing football and you want to hit the ball so as to reach your friend who is 50 meters away. In the field within a short time, what do you think you would do? You would use force. If that friend of yours will need to get that ball as quickly as possible, you'll use at least bigger force. If you wish that ball should reach there at least with a more time, then you may use little force. Therefore, I think we can conclude that force can be measured. So you will use the same energy as when you want the ball to reach him slowly, or you realize that for the ball to move slowly, you must hit it slightly so that it moves slowly. So when you use more energy, the ball moves faster. When you use little energy, the ball moves slowly. That means force can be measured. So the energy used to move an object from one position to another at a certain speed is called force. Something you need to note. The energy used to move an object from one position to another at a certain speed is called force, which means this information is giving us another clue of how we might work out this type of force if we don't have the real or the realia or something that we might see with our naked eyes. So force is calculated as follows. Force is equal to mass of what? Mass of the object you are calculating, and the acceleration, which in other ways is the speed that we have just shared. Acceleration, the way how that object is moving. So mass is weight of the object being moved, and acceleration is the speed of which the object moves at. So it is measured in meters per second, meaning how much or how many meters it is covering in a second. So it is measured in such a way. Now, assuming we want to measure that force and we are taking it into a field and you want to measure this force. So the materials we might need, a ball, like what we have just demonstrated, that you want to pass a ball, and then that could be the ideal example as we want to see more on how we may calculate this force. A weighing balance and a tape measure and a stopwatch. What do you think could be the meaning, the reason for bringing a weighing balance? To measure the weight of the ball, a tape measure to help in measuring the distance that a ball is going to, and then a stopwatch or a stop clock to use or to calculate time taken. Now this could be the procedure for you to use. Remember, this is a very big task. You may not do it alone. You may do it in pairs or in a group. That will help you to correct results. You might not do this alone. So move out to the school field where you might do this experiment properly. Then let 2 students stand in the field at a distance of 50 meters apart. Then using a weighing balance, weigh the ball and record its weight. 4, give the ball to 1 student. Then set the stopwatch. I said 1 student. In that case, 1 of you should have that ball, and then you'll be required to pass that ball to another friend of yours in that kind of a field. And some should hold the stopwatch. That's why I said you should be in a group whereby you can properly do this. Then ask the student to hit the ball straight to the other student, which means ask that friend of yours that to pass the ball to the other friend so that we see the speed and the time taken for that ball. Then start the clock as the foot of the student hits the ball, and stop the clock as the ball reaches the other student. Yeah, so that could be the best explanation on that. But something to note, time taken by the ball to travel the 50-meter distance, that should be taken note. And then ask the student to repeat the procedure several times, alternating hitting the ball hard and hitting it slightly so that you get a variety of the results. Then this could be the table of your recordings so that you compare what you have been finding. But now, in the situation where we have a table of your recordings, and then remember, as we started how to find force, we said force can be found with multiplying mass and acceleration. But in this case, we have another factor, which is time. Do you note something there? How will you happen to calculate this force now? You have the weight, you have the speed, you have the distance covered, and then you have the time taken for this ball to travel to a friend. But how will you calculate this force? Remember, as far as you were giving your safe records, you calculated distance, how the ball traveled, which was 50 meters, and then as the person was hitting this ball, whether it was moving slightly or moving faster, you were recording time, I think. So the distance covered with the time will help you to find speed. As you divide distance with the speed taken, the time taken will help you to find the speed, whereby we'll still come back to the formula of force, which you multiply mass times speed. So for you to substitute distance and time, you make simple divisions, whereby you divide distance, dividing with the time taken. Record yourself to the primary section where you are calculating time. It will still applies the same way, where you divide distance and time, you still find the speed. So mass times speed can still be found as you make that kind of mathematics. So this formula I have also brought to you here so that you have more knowledge about what we are just sharing here. Force can also be found as you multiply mass times. Instead of acceleration or speed, we have substituted distance that you have just measured and the time you put in seconds here, or the time you put time you put in seconds here. So if you divide, you will still find the speed or acceleration of that ball. That has been a very nice lesson to you, I think. And I think you have enjoyed this biology lesson where we have just been sharing and recording measurements. So this is the end of this lesson. Next time we meet, we shall look at study skills that we might follow as we study biology. Thank you very much for being there, and thank you very much for being a good listener. I think you'll still be following this biology lesson as we continue learning more and more in this biology. Thank you very much for being a good listener. Thank you.